Hello everyone, this is Rakshita M of CSE AI Department 7th SEM from Sri Venkateshwara College of Engineering. I'm here to talk about IoT networking components. The contents are introduction, core networking components, communication technologies, data processing and cloud connectivity, challenges in IoT networking. Introduction. The Internet of Things refers to a network of interconnected physical devices that collect, share, and act on data through the internet. Why are networking components important in IoT? Connectivity, data exchange, scalability. IoT devices need reliable networking to communicate and share data that enhances the connectivity. Effective networking components allow seamless data transmission between devices, gateway, and cloud services. These are known as data exchange. As IoT network grows, networking component must support an increasing number of devices and data flow. Core networking components in IoT. The core networking components are sensors and actuators, IoT gateways, network protocols. In sensors and actuators, sensors collect the data from the environment, example temperature, light, motion, etc. The actuators perform action based on received data, example opening values, turning on lights, etc. Next are IoT gateways. It serves as a bridge between IoT devices and the internet or cloud. The functions are data aggregation, protocol translation, edge processing. In data aggregation, it collects and consolidates data from multiple devices. In protocol translation, facilitate communication between devices using different protocols. Edge processing. It pre-processes the data before sending it to the cloud, reducing latency and bandwidth. The third one is network protocols. In network protocols, there are three types of protocols. One is message queuing telemetry transport. It lightweight protocol ideal for low power, low bandwidth devices. Constrained application protocol designed for simple constrained devices. HTTPS protocol, a hypertransport text protocol used for web-based data exchange, secure data transmission. The main purpose is it ensures the reliable and efficient communication across devices and systems. Communication technologies in IoT. Short range communication, long range communication, cellular communication, satellite communication. The main four technologies are short range, long range, cellular, and satellite. In short range, examples are Wi-Fi, Bluetooth, Zigbee, where Wi-Fi is used for the high-speed data transfer and Bluetooth and Zigbee is for the low power, and it's also commonly used for personal devices and wearable devices. And long range communication such as LoRaWAN, long range low power, ideal for rural areas, wide area IoT networks. NB-IoT, narrow band technology. LTE-M, enhanced LTE for IoT with better mobility and voice capability such as Airtel LET, such are the examples. Cellular communications are 4G, 5G, 3G. It is consists of high data rates, low latency. It is an ideal application for high data throughput and quick responses. And then comes the satellite communication. It connects devices in remote or unreachable areas where other network types are used, such as satellites. Main use cases are environmental monitoring, offshore oil rigs, and agriculture in remote areas. Data processing and cloud connectivity in IoT. There are two types of data processing or cloud computing, cloud connectivity, that is edge computing and cloud computing. In edge computing, it processes the data locally near the source of data generation rather than sending all data to the cloud. But in cloud computing, it sends the all data to the cloud. And the benefits of edge computing is reduced latency, quicker response times for real-time application, lower bandwidth use, less data sent over the network, reducing cost, And the main use case is it is ideal for the application that require immediate processing like autonomous vehicle and industrial automation. And the cloud computing is the main functionality. It has the data storage and data processing and analytics where the complex data are analyzed, and it is also applicable in machine learning and visualization. And the popular cloud platforms are AWS, Amazon software, and Microsoft Azure, Google Cloud IoT Core. And the main use cases is to store the extensive data, and it is also used to analyze the data for the long term. Security components in IoT: encryption, authentication, access control, network monitoring and intrusion detection, firmware and software updates. In encryption, it protects the data as in transit and it at the rest also. The main methods are advanced encryption standards, wherein authentication it verifies the identity for the sender or the to prevent the unauthorized access, where it consists of a method such as digital certificates, some tokens, etc. And the access control is in it consists of an some authentication or authorized users or devices to have access to sensitive data and controls, such as it can use role based and access based access control, attribute based access control. The network monitoring and intrusion detects this mechanism is to detect the unusual activity in the cloud to indicate the security threat. This consists of intrusion detective system and intrusion prevention system. This helps to respond to threats. And the firmware and software updates keep devices secure by regularly updating with the latest security patches. Methods are over the air OTA updates, ensure the devices can receive updated remotely. Challenges in IoT networking: scalability, interoperability, latency and reliability, security and privacy risk, power consumption. Handling the rapid growth of IoT devices and the vast amount of data they generate, it impact the network infrastructure and must support increased data traffic. And in interoperability, ensuring diverse IoT devices and system for different manufacturers can communicate and work together seamlessly. The impact is lack of standardization. It can lead to the compatibility issues. Latency and reliability: maintaining real-time communication and consistent performance is very critical. And in impact, it consists of an high endurance of IoT applications that demand on immediate response, like healthcare or autonomous vehicles. Security and privacy risk: safeguarding sensitive data and ensuring device security against cyber threats. IoT networks are often vulnerable to act and due to multiple access points. Power consumption: many IoT device relies on battery, which needs to be optimized for long term. This have an impact of high power consumption, can limit the device functionality and require frequent maintenance. Future trends are integration with artificial intelligence, adoption of 5G for IoT, faster speed, lower latency, and virtual reality, augmented reality, AR, VR, and enhanced autonomous systems, increased focus on IoT security, cyber attacks, improving data privacy, and user trust. I hope everyone are very clear with the topics, and thank you for watching my video.